Hi, we want to talk today about what a function is and also what function notation is. So we have something called relation in mathematics, which is just a set of ordered pairs, basically a combination of x, y points to make it easier to understand. So how can you represent them? You have different ways. You have something like that, that's called mapping. This is a table of values. This here is the graph. This here is also an example of mapping. So this is where a mapping shows us that this -1 here goes to 2, and this 0 here is paired with 2 as well, and 1 goes with -3, etc. Here it's pretty easy. The graph shows you the same thing on the graph where you can figure out the points. So some relations are functions, but that requires something to happen. So we define a function as a relation in which for every element of domain, which is our input value or independent variable, there's exactly one element of range, which is our output value or dependent variable. So how to determine if a given relation is a function, you can do it numerically, graphically, or algebraically, depending how the relation is presented. So you can analyze a table of values or mapping, and what you're trying to see there, if you don't have more than one element of domain, there may be a situation when the same element of domain goes with two or more elements of range. I want to show you that example. So you actually have two mappings here. So if you look at this one, you see that for every value of x, which is our input, our domain, this is our range, every value here is paired with only one value of range. Right? -1 goes with 2, 0 goes with 2, 1 goes with -3, 2 goes with -2, and 8 goes with 3. So this is an example of a function. And I will show you difference here with this one. This is not a function, because what you have here, this is our domain and range, you have this element here, 7, which is actually paired with two different elements of range. In other words, you have 0.71 and you also have 0.74. This is not allowed in a function, so this one is not a function. Okay. Now, how do you do it with a table of values? Well, same concept. You don't want to see, basically in the table you don't want to see a repetition of the same x value and then here it's going to go with two different y values. So this is a function, because for every x there's exactly one y, no more than that. So this here is a function. Okay, so let me go back. I'll come back to this one problem. What do you do with graphs? Well, with graphs, there's something called a vertical line test, and with the vertical line test, you don't want to intersect the graph at any location with a vertical line, so it goes through more than one point. Sometimes people call it the pencil test, and the reason they call it that is because a teacher would tell your students, go ahead and grab a pencil and hold it vertically. And, you know, it doesn't have to be a pencil, but if you look over here, this line, this vertical line represented by my pencil, crosses my graph at more than one point, right? As a matter of fact, it happens in a lot of places. Now here it only crosses at one point, here it doesn't cross at all, but that's not going to matter because you don't want it anywhere. You don't want more than one intersection. So this here is not a function. All right. So hopefully we got this straightened out. But there's one more way to do that, that's analytically. That's when you analyze the formula. So if you can show that y, for every x there will be a unique y, then you have a function. So this one actually is an example of a function because y is our independent variable, x is independent. So for every value of x I'm going to put here, I'm going to get only one value of y. This is a function. So you can probably understand that the next one I'm going to show you is not, but let me show you why. So we want to solve it for y, for our variable y. So I'm going to write y squared equals 9 minus x squared. And now I have to take the square root. But remember, in situations like this will be plus or minus square root of 9 minus x squared. Okay? And what happens is, here if I pick a value of x and I put it in here, what's going to end up happening is I'm going to get a square root of some number, but there's going to be plus or minus. So for every value of x that's going to work in this function, I'm going to end up getting two different values of y. And that is not something we can allow, so that's not a function. Alright, let's move on and talk about functions. So how do we understand what a function is in general, and how domain and range are related? So under domain we understand the set of all the input values, all of them. So every single value that can be input into your function is considered to be an element of domain. That is going to be the values of our independent variable. And the output that you get for, so you plot, this is how basically we understand a function. There's some concept that people usually refer to as a function machine. So we have an input, there's some rule that the function follows, and then it spits out the output. Okay, so in our case the range is going to be comprised of all the output values that we're getting for every input. Okay, so it's the set of all output values that are a dependent variable, and it's going to include all possible values of it. So what is a function notation that we need to know? Typically it's written like this: f of x. It's not always going to be f. Sometimes they use other letters, but it's going to be f of x. You pronounce that as f of x. Okay, so f is going to be the name of the function, x is our independent variable or our input, and on this set it's going to give you the rule that's actually going to tell you what to do with x. Okay, in this case it tells you multiply your x values by 2. Okay, any kind of formula that you're going to see there is going to tell you the rule, so that's the rule that goes here. So we take our x, that's input, so if you pick a particular value of x, you put it in here and you're going to calculate this, and that's going to give you your output. Functions can be presented most of the time 3 different ways. You can do it numerically, which is a table of values, which is right here. You can also present them graphically, which is very nice and visual. We use graphs in our real lives. And also you can do it algebraically. Algebraically would be when a formula is given, so something like that. In this case, I actually used a different letter. I didn't use F, I used G. So that's perfectly fine. You can use any letter you want. You do not have to use only F. Alright. There's one other aspect of functions that we want to talk about, which is continuity. Now, I do want to mention that the concept of continuity is somewhat of a challenging concept as far as discussing that, and there's a formal definition of that in calculus and mathematical analysis. So for what we're trying to do now, you just need to understand that intuitively. So we should understand the graph to be continuous if it has no breaks or holes. And that means if I want to try to graph my function, I should be able to do it without lifting a pen or a pencil. So this here is an example of somewhat of a complex but a continuous function. It has no breaks, no holes, and that's what it is. So then a question, of course, is going to be, what do discontinuous function look like? What types of discontinuities we have. There are actually 3 types of discontinuities that we recognize. So the first one is going to be a hole. That means you have a graph, but it does have a hole. Let me zoom in quickly on that one so you can see it. So right there, this function has a hole. Okay, there are reasons why it can happen, but That is one example. This is actually what we call a removable discontinuity. The reason it's called removable is if we plug that hole with a value, then you no longer have a hole and the function is going to become continuous. This is the only type of a removable discontinuity, when you have a hole. The other two types are non-removable. So the other one is a jump. That's when the function jumps from one value suddenly to another one. Doesn't matter how much it's going to jump, it's still a jump, and it's a separation of these two parts, and there's a break in the graph. You can't draw this function without lifting your pencil. And the third type is when you have a vertical asymptote. That's when you have an infinite discontinuity. That's when the graph is going to start approaching a certain value from the left and right of that, but it will never reach that value. Like in this case, for this function, the value of x cannot ever be 3. Alright, and this is how this works with functions. I hope this helps.